In this tutorial, we will be discussing organic compounds. Organic compounds are made primarily of carbon and hydrogen. However, it could contain other things like oxygen, sulfur, nitrogen, phosphorus, or a halogen. Notice that these are all nonmetals. When they contain these here, that's going to change how it reacts. That's why those items are important. These are often found in things like gasoline and medicines, shampoos. Our bodies are made of organic compounds. Our cells are made of organic compounds. So organic chemistry is an extremely important part of chemistry. So, in general, organic compounds typically have covalent bonds, low melting and boiling points, which is why you'll typically find them as liquids or as gases. They're flammable, which is why we can set wood on fire when we're trying to have a bonfire. And they're not typically soluble in water unless they're containing one of these. Vegetable oil here is not getting dissolved in the water, it's just floating on top of the water because vegetable oil is an organic compound. Inorganic compounds, however, have very high melting points and boiling points, which is why they're typically solids at room temperature. Inorganic compounds that are ionic are usually soluble in water and typically do not burn in air. This is an example of propane, which is an organic compound, and this is table salt. Notice the difference in how they're formed. The inorganic is ions that are alternating into a solid, whereas there's space between the propane molecules because they're individual molecules rather than a cluster. So let's compare organic and inorganic. The elements present for organic is typically carbon and hydrogen and possibly some other ones, whereas inorganic is pretty much all of them. Organic compounds are molecules, while inorganics are typically ions. Organic compounds do covalent bonding, while inorganic one does ionic, and some are covalent, but they're mainly ionic. The polar bonds, the organic chemistry are typically nonpolar, which is why they don't dissolve in water. Unless, once again, you have one of these things in here that are more electronegative, that's going to make the electrons get attracted to them and therefore create a polarity. Inorganics, or most, are ionic and a few polar covalent. Melting points and boiling points are usually low for organic and high for inorganic. They're flammable for organic. Inorganic don't typically burn, which is why you really can't burn salt. And organic is typically not soluble in water, while inorganic is. So let's go through and see what we can remember. Which is inorganic and which is organic? It has a high melting point, that would be inorganic. It's not soluble in water, that means it's inorganic. Has the formula of CH3, CH2, CH3, those are all carbons and hydrogens, that would be organic. Formula of MgCl2, there's no carbons or hydrogens here, that's inorganic. Burns easily in air, that's organic. And has covalent bonding. They both have covalent bonding, but organic is typically made almost exclusively of them. So hydrocarbons is a subset of organic chemistry. It contains only carbon and hydrogen. Those are very, very common. So organic chemistry in general contains oxygen, nitrogen, sulfur, halogen, so on and so forth. Whereas hydrocarbons are solely carbon and hydrogen. Each one of these carbons has 4 bonds. 1, 2, 3, 4. That is super important. That's going to be very helpful from now until the rest of the semester. You need to remember that. You know this by looking at the periodic table. carbon is in this row here with 4 electrons around it. So it has 4 dots around it, and each one of those dots then creates a bond. And that's how it gets 4 bonds. No matter what, carbon will always have 4 lines going off of it. If it's saturated, that means all those lines are single. It is possible to have unsaturated where you have double and triple bonds, but right now let's focus on the saturated. Methane is one example. This is written as the electron dot. Here's the expanded structural formula. And this is what we call ball and stick. That's where you actually make models in the lab. And every single one of these pictorial demonstrations, they're all 4 lines coming off of it. They all have 4 bonds coming off of it. Because of the 4, that's making it tetrahedral. That is how the angles are. This 109.5 here, that 109.5 is telling you that that bond angle is 109.5. That's if you were to spread out the atoms as much as you possibly can, that's what the angle would be. So each one of these is spaced out 109. Once again, tetrahedral. Remember that word. It's an important word. Here's ethane. Once again, there's 4 lines coming off of each carbon. When you have 4 lines coming off of each carbon, 4 lines coming off of any atom with no lone pairs, once again, tetrahedral. So a butane molecule, C4H10, predict the shape around each carbon. Notice how there's 4 lines coming around, that's tetrahedral. 4 lines going around, tetrahedral. 4 lines, tetrahedral. 4 lines. Each one of these are tetrahedral because you have 4 lines coming off of it. And each carbon is bonded to 4 things. That is your introduction to organic chemistry.